Picture this, it's June 2024. Two American astronauts, Butch Wilmore and Suni Williams, rocket into the sky aboard Boeing's brand new Starliner. This launch is the result of years of work and billions of dollars a second American spacecraft, alongside SpaceX's Dragon to reach the International Space Station. The world watches as Starliner blazes upward, a symbol of progress. But space is unforgiving. Soon after reaching orbit, alarms sound. Starliner, named Calypso, isn't behaving as expected. Mission Control detects strange readings. The astronauts and ground teams begin troubleshooting at 17,000 miles per hour. What was meant to be a short, triumphant flight quickly turns into a tense drama. The culprit: helium leaks. Helium, essential for pushing fuel into the thrusters, is escaping from multiple spots. Some thrusters stop working. Starliner's ability to steer is compromised. Docking with the ISS becomes a white-knuckle event, requiring immense skill. The mission, planned for a week, stretches on. The world waits. The astronauts are safe on the ISS, but their ride home is in question. The problems are too significant to ignore. Could Starliner bring them back safely? After intense analysis, NASA and Boeing make a tough call. Butch and Suni will return to Earth aboard a SpaceX Crew Dragon. Starliner will come home empty. It's a dramatic, humbling decision, a setback, but not the end. The mission exposes critical flaws but also sets the stage for a comeback. Starliner's journey is far from over. This is the reality of space exploration: triumph, challenge, and the relentless pursuit of progress. Every setback is a lesson. The world is watching to see what comes next. For Boeing and NASA, the stakes have never been higher. The dream of a second American crew vehicle is on the line. The comeback story begins now. So, what exactly went wrong? Two big issues: helium leaks and thruster failures. Helium, used to push fuel into Starliner's thrusters, began leaking from multiple places. Before launch, a small leak was found. Manageable, they thought. But in orbit, 5 leaks appeared. Every bit of lost helium meant less maneuvering power. Then, during docking, 5 of 28 thrusters failed. These thrusters are vital for precise movements. Think parallel parking with a broken steering wheel. The cause? Overheating. Long burns during docking pushed them beyond their limits, triggering automatic shutdowns. The combination, leaking helium and overheating thrusters, made Starliner unreliable. For a crew vehicle, that's unacceptable. The mission revealed fundamental design issues. Starliner couldn't be trusted to bring astronauts home safely, yet. The problems demanded a total rethink. The path forward would require deep engineering fixes. Well, let's look under Starliner's hood. The service module, home to the propulsion system, was the focus. Helium leaks traced back to faulty seals, tiny components that failed under space's extreme conditions. The original seal material degraded, letting high-pressure helium escape. Meanwhile, the thrusters overheated because they were fired longer and harder than designed. Their safety systems shut them down at critical moments. The root causes: a material science problem with the seals and a thermal management problem with the thrusters. These aren't quick fixes. Boeing and NASA had to rethink the design, materials, and flight rules. Only real spaceflight revealed these hidden flaws. The next step: redesign and rebuild. When things go wrong, you learn and adapt. NASA and Boeing's first task: fix the helium leaks. Engineers are testing new seal materials, strong, flexible, and resistant to Starliner's propellants. They're also redesigning the seal housings for a tighter fit. Next, the thruster overheating. Software updates will change how Starliner flies. Shorter, smarter thruster bursts to reduce heat. Hardware changes are coming too. Better insulation and improved heat dissipation in the thruster pods. Engineers are building better computer models, using real flight data to predict and prevent future problems. A stuck valve during the mission led to another fix: new systems to cycle and check valves before critical burns. Every change is tested, retested, and validated. The goal: a safer, more reliable Starliner. Science-driven problem-solving is at the heart of the comeback. Each fix brings Starliner closer to flying again. Failure isn't the end, it's the start of smarter engineering. You can't just hope a fix works, you have to prove it. At NASA's White Sands test facility, engineers are putting Starliner's new systems through brutal tests. A full-scale replica of the service module faces real helium, real propellants, and vacuum conditions. New seals are tested for leaks. Thrusters are fired in long, demanding patterns. Engineers measure temperatures, validate software, and push hardware to the limit. Every test is a step toward regaining trust. NASA needs absolute confidence before astronauts fly again. The data from White Sands will decide Starliner's future. This is the unglamorous, essential work behind every safe mission. Only when the fixes survive the toughest tests will Starliner return to flight. The comeback is built on proof, not promises. The next chapter depends on what happens in the desert. Why does Starliner matter? One word: redundancy. The ISS can't rely on a single spacecraft. Two American crew vehicles, SpaceX's Dragon and Boeing's Starliner, are essential. After the space shuttle retired, the US depended on Russian rockets for nearly a decade. The Commercial Crew Program was created to end that reliance. SpaceX delivered in 2020, but the vision isn't complete until Boeing joins them. For Boeing, Starliner is a test of reputation and survival. Years behind schedule, billions over budget. Success is crucial for Boeing's future in spaceflight. Competition drives innovation and keeps costs in check. Two providers mean NASA gets better technology and value. A monopoly risks stagnation. Competition ensures progress. Starliner's success is a national priority, not just a corporate one. The stakes: American access to space, innovation, and leadership. That's why getting Starliner flying matters. What's next? Starliner's path forward is clear. After ground testing, Boeing and NASA will launch an uncrewed Starliner to the ISS in 2026. This mission is the ultimate test. Every system, every fix under real conditions. Engineers will watch for leaks, monitor thruster temperatures, and demand flawless performance. If Starliner passes, the next step is a crewed flight. Wilmore and Williams return for a true validation mission. Success would mean two American spacecraft at the ISS, a symbol of resilience and ingenuity. Starliner's journey is about learning from failure and coming back stronger. Space exploration is built on setbacks and comebacks. The 2026 mission is Starliner's shot at redemption. It carries not just cargo, but the hopes of engineers and a nation's ambition. The dream: two robust paths to the stars. The challenge proves Starliner is ready. The story isn't over. It's just getting started. Let's get it done.